Welcome to Grad Summer School. I'm your TA, Claude. This is Week 0, an introduction to the Linux development environment. I won't read through the table of contents line by line, but here's the route. We'll go from the ecosystem to the desktop to the shell to the file system to permissions to package management to path, and finally land on System D. First, a word for anyone who just started their master's and is feeling a little lost. It's completely normal to walk into a lab with no background. The point of this Linux intro is to help students with no relevant background keep up with the courses that follow. Even if you've never actually developed on Linux, don't worry about it. The whole purpose of this summer program is to help you fill in the theoretical foundations and build good development habits. That said, even though this is meant to bring people with no background up to speed, you did get into grad school, so you presumably have at least the basics from an operating systems course, right? Heh, I'll assume nobody bought their way in. This week, we're keeping the scope to the workflows you'll use day to day. Think of it as the foundation for your debugging ability down the road. We're not psychics. Finding the root cause of a problem takes gathering clues. This week's material is what helps you figure out which direction those clues point. Here's what you should be able to do by the end of this course. Section 1. The Linux ecosystem and distributions. When we say Linux, what exactly are we talking about? As you know, the kernel handles hardware, processes, memory, the file system, networking, drivers, and system calls. User space, or userland, is everything else: the shell, compilers, libraries, core utilities, various services, and the desktop. You've taken an OS course, so those two layers should be familiar. What the textbook doesn't cover is the layer on top, the distribution. A distro picks the kernel and userland, integrates them, packages them, tests them, and provides updates and support. A lot of this ecosystem is actually historical baggage. Unix set the conventions back in the 1970s, multiple users, files as the universal abstraction, small tools composed with pipes, configuration written as plain text. Those ideas still shape everything today. The backdrop in the 1980s was Unix going commercial. AT&T started seriously collecting license fees. The various vendor Unix is splintered apart, and source code stopped flowing freely between universities the way it had in the earlier years. Against that backdrop, the GNU project set out to write a Unix-like system that anyone could freely use, modify, and redistribute. By around 1990, that project had built out almost the entire userland, but it was still missing one piece: a working kernel. In 1991, Linus Torvalds released the Linux kernel and switched it to the GPL the following year. That was a turning point in history, because the two licenses were compatible, which let the community legally pair the GNU userland with the Linux kernel. Slackware and dev.en were born in 1992 and 1993. The role of assembling these two worlds together is exactly what a distribution does. You could say the kernel and userland have been separate projects, maintained by separate communities on separate schedules, since day one. Someone has to take on the job of integrating them. And that's usually where someone asks, TA, what is the distro actually selling? Simply put, a bundle of integration decisions, plus a promise to stand behind those decisions. Which system components ship by default? Do package versions lean new or lean stable? Is the update model rolling release or fixed release? Package format, security mechanisms, how long support lasts. Every distro has its own dialect for the same set of questions. For example, to install C and C++ development tools, on Ubuntu you'd run sudo apt install build essential, on Arch, sudo pacman, sbasedevil on Fedora, sudo dn, fgroup install development tools. That brings us to the distro families. The same way you can tell something about a person from their surname, you can tell something about a distro from its family. First, the dev.en family. They value stability and the free software tradition. Dev.en itself is famously conservative. Its stable release runs old versions, but reliably so. Ubuntu takes dev.en as its base and adds aggressive hardware support, desktop integration, and commercial support. The Red Hat family is the one you find in enterprise server rooms. RHEL sells long-term support, a stable ABI, and a commercial contract with someone on the other end of the phone. Fedora is its bleeding-edge testbed. A lot of new technology shows up on Fedora first before it's mainstream anywhere else. The Arch family runs on a different philosophy entirely: minimal, transparent, and it's on you to take care of your own system. If an update rolls in and breaks something, well, that's on you to fix. I use Arch, by the way, is a running joke in the Linux world. It comes from a certain smugness some Arch users have online, like acing a brutal exam and then somehow working your score into every conversation afterward. That said, the Arch wiki genuinely is some of the highest quality documentation in the entire Linux world. I'd recommend browsing it even when you don't need anything specific. A few specialized players worth knowing: Alpine, the favorite for containers. NixOS is genuinely cool. It manages the entire system through declarative configuration, which gives it excellent reproducibility, at the cost of a real learning curve. And Kali is basically a full toolkit for security testing. It's meant to be a testing environment, not a daily desktop. Enough talking, let's get hands-on. The handout lists a few commands, uname, shows the kernel version, and CPU architecture, cat/etc/os, -release shows the distro, lsb release A, and hostname control work too. Those two commands answer questions at different layers. The same version of Ubuntu can run on different kernels, which is basically proof of the three-layer model we just covered. The most noticeable difference between distros is the package manager, which I already snuck in a mention of earlier. I'll hold off on that for now. We'll dig into it properly in the package management section. Section 2, the desktop environment and the display system. Here's a fact most people have never really thought about. The vast majority of Linux installs in the world have no screen attached at all. Walk into a server room, a whole rack of machines lined up, and not a single one has a monitor plugged in. That's not an engineer forgetting to hook one up, that's deliberate. If you walk through the boot sequence with me, this will make sense on its own. You hit the power button, and first UEFI, or on older machines, BIOS, runs a hardware self-check. Once that's done, it hands off to grub. What grub actually does is let you pick which kernel to boot and what boot parameters to use. If your machine dual boots, that menu that pops up at startup is grub drawing it for you. After grub wakes the kernel up, the kernel first mounts a temporary root file system called initram-ss, stuffed with whatever driver modules are needed right at boot time. Cases like an encrypted disk, RAID, or booting over the network all need this temporary layer to recognize the real disk first, so it can then hand off to the real root file system. This step is actually pretty critical. People just never notice it's there. Once that whole handoff is done, systemd, what we call PID1, officially takes over. At that point, the system is fully up, processes can run, files can be managed, the network can come up, services can start. The desktop is the very last layer stacked on top, and the whole layer is optional. You can skip it entirely. Spin up a VM in the cloud, and it's running in seconds, and nobody along the way ever thought about giving it a monitor. The reasons for skipping the desktop aren't hard to understand. First, a desktop eats memory and CPU, resources a server would rather reserve for your training job. An idle desktop environment sitting there, just running in the background, still eats a few hundred megabytes of memory. Converted into training resources, that's not a trivial amount. Second, installing a graphical interface is one more attack surface. Nobody in the server room is going to be staring at a screen anyway, so it's installed and never used. Plain and simple, that's your waste, and it's one more thing security audits have to check. Third, and the most practical reason, without a desktop, remote management is actually simpler. A single text interface gets you everywhere. Kids these days who've only used Windows probably find this hard to believe. With no desktop, how do you even control the machine? When the desktop dies, there's an escape hatch called TTY. The name comes from teletype, a genuine holdover term from the days of physical teleprinters. The old convention was to boot up 6 plain-text consoles, each running a small program called Getty that handles the login prompt, with the graphical desktop typically layered on top of one more virtual console. Switching over is simple. Control, Alt, F3 gets you to a plain-text login. To switch back, just hit F1 or F2. Here's the rescue scenario, and a lot of people have genuinely hit this one. You update your NVIDIA graphics driver, reboot, and the screen just goes black, or the whole thing freezes. Switch into a TTY, log in, stop the display service that's causing the problem, glance at the logs, figure out which driver broke, and the system can usually be recovered. That works because when the desktop dies, TTY is often still alive. The desktop environment itself is really a layer of integration. A DE bundles the window manager, panel, settings daemon, file manager, input method, and power management all together for you. There's something the handout doesn't call out separately, but I think it's worth keeping straight. The account selection screen you see before you even log in is actually a completely separate piece of software called the Display Manager. GDM, SDDM, and LightDM all fall into this category. It's a distro project from the GNOME or KDE you actually use after logging in. The two just hand off to each other in sequence. GNOME goes for consistency and simplicity. It's Ubuntu's default, a customized build of GNOME, which is why its login screen is GDM. KDE Plasma, on the other hand, lets you tweak nearly everything. Tweak it enough and you might just give up. XFCE and LXQT go for the lightweight route, and they're the usual choice for older machines. The same machine can actually have several DEs installed side by side. That unassuming little gear icon in the corner of the login screen is the display manager letting you choose which DE to load this session and which type of session to use. A lot of people have used it for years without ever clicking it. That same menu is also where you switch between X11 and Wayland. There's another crowd that installs only a window manager and assembles their own desktop by hand. i3, Hyperland, and Sway are the names you'll hear most from this group. It's a keyboard-driven approach where window layout is entirely dictated by config files, and you barely touch the mouse to open or arrange windows. What this really demonstrates is how modular the Linux desktop can be. You won't use it much for day-to-day research, and it's completely fine if you never do. Just know the option exists. Below the desktop, there's another layer called the display system, responsible for how the picture actually gets drawn on the screen. The old guard is X11, born in 1984 out of a project at MIT called Project Lena. Its name continues from Stanford's earlier W window system, just the next letter of the alphabet, a bit of old-school engineer humor. X11 has a fairly counterintuitive design. The machine sitting in front of you, the one doing the drawing and collecting your input, is called the server. The actual application, even if it's running on a remote host, is called the client, because it's the one requesting drawing services from your screen. That naming is the exact opposite of what most people picture in a typical client-server network relationship, and almost everyone gets it backwards the first time they run into it. X11 had a feature that was genuinely ahead of its time. Network transparency, SSH-X, can take a window opened on a remote host and display it directly on your local screen. The display environment variable is the legacy it left behind. It records which X server should receive that picture. The cost is 40 years of accumulated complexity, plus the security issues that come with it. In theory, any program that can connect to that server can peek at your screen or capture your keystrokes. X11's successor is Wayland, already the default in both GNOME and KDE. Architecturally, it merges the window manager and the display into a single role called the compositor. One less hop, better performance, and better security. But it's much stricter about permissions. An app that wants to take a screenshot or share your screen can't just reach in and read the screen contents directly. It has to go through a mechanism called a portal, which pops up an explicit permission dialog asking whether you consent. A lot of older software still hasn't learned how to talk to this mechanism. Let me add a few things from real-world experience that the handout doesn't cover, but you'll almost certainly run into. First, SSH-X sounds great on paper, but in practice it's piping the entire window frame by frame over the network. Basically, too slow for anyone to want to try it twice. For anything closer to a full remote desktop, tools like VNC or X2 go compress the whole desktop picture and stream it, which runs a bit smoother than SSH-X, but at the end of the day, you're still transmitting a picture. The real mainstream approach is to just not transmit the picture at all. Modern editors almost all ship with matching remote development tools, VS Code's Remote SSH, for instance, or some people just run something like Jupyter Lab as a web interface. Second, when you're on a video call sharing your screen and it can't grab a particular window, that's usually not the software breaking. That's the portal mechanism I just mentioned doing its job. By default, it won't let an app just grab another window's contents. You have to explicitly pick, in that system dialog that pops up, which window or which whole screen you want to share. If this whole thing is driving you crazy, honestly, my advice is just run your meeting software from the Windows side, unless you actually enjoy fiddling with this stuff. By the way, NVIDIA's graphics drivers and Wayland have been at odds for years. The problem really comes down to how the two sides handle syncing graphics memory, and it's only in the last few years that newer driver versions have gradually added a compatibility layer. If you want to figure out which world you're currently living in, here's a lineup of commands: echo xdg current desktop, echo xdg session type, echo display, echo $, Wayland display, and login control, which lists your current login sessions. LSPCISK shows which driver module your graphics card is actually using. When a graphical program refuses to open, the classic error is cannot open display, which, read literally, is describing exactly that counterintuitive X11 client-server model your program can't find anyone to request a picture from. Check things in this order: session first, then display protocol, then permissions, and only then start suspecting the driver. Most people check in the reverse order, and that usually just means a much longer detour.